my pleasure. I think it's partly due to the topic, but there's those presenters that just really enjoy their jobs. Denise, with that, I will turn you loose.
All right, great. Thank you. Let me share my screen and see if we're good here. Thanks so much for having me. So folks, I'm with the Department of Entomology at OSU based out of Worcester, but I have a statewide appointment, and really since the pandemic have been based either out of home or out teaching. Thank goodness, lots more in-person teaching now. So my main focus is pollinator education, BID, conservation, creating habitat. But tonight we're going to focus on phenology, which is something I've been doing even longer than I've been focusing on pollinators. I was a county extension educator in the Akron-Canton area in Stark and Summit counties for the first half of my career for about 18 years, and worked with Dan Herms on the phenology calendar and a replicated planting across the state where a lot of sites were studying phenology and demonstrating how you can use phenology in pest management and all kinds of other things. So tonight our focus is on phenology. Van, I forgot to ask how long you want me to drone on, because I love phenology. I don't want to go longer than you have in mind.
Well, typically we've went anywhere from 45 minutes to 2 hours.
Okay, won't be 2 hours, folks. Don't sign out.
yeah. So, I mean, if you're at that 45 to an hour, and then questions, or
perfect.
I mean, I think this is something that's interesting. It's fairly new for a lot of folks, including myself. So we'll just see how the group goes. How's that?
Okay, awesome. That's great. That's great. It's hard to, if phenology is not familiar to you, if it's kind of a new concept, it can be hard to scrunch what I teach into less than 45 minutes. Really, I find people have questions, and it's just a little difficult to clarify in a shorter amount of time. Although I can, speed up when I have to. But so that being said, if we have questions as we go, if things aren't clear. And maybe Melissa or Van, you can help me with the chat box. It's a little hard for me to kind of monitor questions as I'm going. But if you see that somebody's, got a question that would be good to address, I'm happy to do that. And
okay.
Then also
do you want them to just type questions into the chat box,
or however you like to do it? Whatever's customary for your group is fine.
Oh, yeah. We're just all over the board.
Yeah, however it works.
All right. Thanks.
All right, so often I teach this group this program to beekeepers, to naturalists, to farmers and gardeners, and a lot of times I do that in winter, because in winter we're really looking forward to things greening up and things blooming, and your mind is really ready for spring. So a little bit of my program is kind of spring focused, but we are going to talk about summer, how to use the OSU phenology calendar, if that's not familiar to you. Some different ways that groups and growers have used our phenology calendar, and some thoughts on how you can keep your own data. So I'd say the worst time to have me come in and teach phenology is probably like September, when the season's really winding down and we're ready to kind of tear things out. We're almost hoping for that first frost just to clean things up. Summer's a little more challenging of a time because it's not as immediate as kind of that late winter, early spring. So that being said, here's one way that I know that spring is coming, and that's when I see the first turkey vulture return to where I live. I'm not far from Worcester, here in Northeast Ohio. And that note on the bottom is when I first saw the turkey vulture return in 2022. In 2023, I saw turkey vultures on and off, not during really cold periods, but I saw them on and off all winter. And I went down to Fairfield County in early spring this year and taught to a beekeeping group. And they kind of had the same observation, that they really were seeing kind of that spread of the time when we would expect to not see the turkey vultures. So anyway, if we think about ways that we know that seasons are changing, the way that that spring is coming, maybe it's birds returning and nesting. Here's the red-winged blackbird, starting to set up their territory. I think of kind of mid-March where I am in this part of the state. And one correlation that I always think of when I hear the red-winged blackbird make that really distinctive call is I wonder if skunk cabbage is in bloom. And I live not too far from Hartville, Ohio. That's the Quail Hollow used to be state park, and now it's a county park. Have a nice wetland area there. And so when I hear the red-winged blackbird start to call, then I think, oh, I wonder if the skunk cabbage is starting to bloom at Quail Hollow. And you can see from this image, the skunk cabbage can metabolize in really cold temperatures and can push through, because of the heat of the plant, can push through ice and snow, kind of melt the environment around it to bloom. So that's really kind of one of the basic ideas of phenology, that we can use one biological cue to predict another event. Okay? I didn't grow up in Ohio. I grew up the first 12 years or so. I grew up in the Laurel Highlands in Western Pennsylvania. And one way that I knew spring was coming up the mountain. We lived up on a top of a ridge that used to be the little community ski slope. And at that time, our roads were gravel with cinders in the winter. And when I saw this plant blooming, this is coltsfoot, on the edges of the road, then I knew that spring was finally making its way up the mountain. So here we can see a honeybee on that coltsfoot flower. And honeybees are really the weirdos of the bee world in a lot of ways. You know, we love that they're weird, that we love that they're perennial, that they store honey, that they're incredible pollinators with huge colonies. But a lot of characteristics of honeybees are much different than other bees. And so when I teach this program for beekeepers, I make kind of that caveat that when we talk about warming temperatures and the development of insects and the development of plants and how those ideas are correlated, and we'll talk a lot more about that, we kind of have to set honeybees aside, because they are able, because they can burn through honey, they can make their own heat in that hive. And so their development is not dependent on the ambient temperature. So they can, as long as it's sunny and warm enough for them to fly, they can be out there flying. Their development isn't dependent on the outside temperature. So most other bees aren't like that. They need those warm temperatures to develop, and then we start to see, the queen bumblebees and the other springtime bees active. Right now around here, we're just finishing up the northern catalpa bloom. By looking at the phenology calendar down around Zanesville, I see that southern catalpa is kind of just coming in to bloom for all of you who are a little further south from me. I love catalpa. It's really one of those plants that makes me think of summer, and the color lines and the runway lights and these little fake anthers on here that make the pollinators think that this is a great pollen reward. They show them exactly where to go. They get tapped on the back by these anthers and go in and get their reward, leave and come back. Catalpa is amazing, and since we're celebrating pollinators this time of year, catalpa changes its sugar concentration in the nectar from night to day. So during the daytime, it sees bee visitors, carpenter bees, bumblebees, maybe honeybees, and they have relatively short tongues compared to the nighttime visitors. And you can imagine this white flower fragrance has moths visiting at night. Moths, relatively long tongues, long, thin tongues. And so they can't suck up a nectar that's really thick, higher in sugar concentration. And so the plant actually, catalpa, customizes its nectar reward from day to night, offering a higher sugar reward during the day for the bees who can take it on with their bigger, smaller, fatter tongues. Then at night, thinning out that nectar so that moths with those long tongues can suck up that nectar. So I just love that that example of these complex relationships that we are so unaware of. It takes really a researcher to go in there and sample that nectar and the sugar concentration to know what's happening. So anyway, the catalpa, we're going to look at the phenology calendar and talk about how we know what's in bloom and what's coming into bloom. But catalpa, kind of our early summer flower of interest. So we're talking about phenology and not phrenology. Phenology is the study of biological occurrences and how they relate to weather and climate. Phrenology is the pseudoscience that says that the bumps on your head can tell whether you're a liar, an adulterer, a very honest person, et cetera, et cetera. So it's a very, it has roots, it's a pseudoscience. There's no reality to it. It has a lot of roots in racism. So we're not talking about phrenology, we're talking about phenology. So phenology is the study of what shows or appears and how those, as I said, how those biological events are related to climate and weather. And so there are a lot of different ways to think about phenology. And I put some kind of human examples, kind of our cultural examples, but really in phenology, we're talking about the biology. So, you know, if you're a bird watcher, you kind of know which birds, if you're watching ducks or other waterfowl, you kind of know which ducks are the first to return to Shreve. If you go to the wetland area to watch that migration, you kind of know, you know, which ducks are early, which ducks are kind of mid-migration, and which are later in the season. And that's very much related to the climate and the weather. Maybe you're into wildflowers and you really know that kind of succession of bloom from skunk cabbage, you know, through geraniums and all the way down to goldenrods late in the season. There's this whole progression of bloom that relates to temperature and day length. If you suffer from allergies, you definitely know phenology. Right now, the grasses are in full bloom, and so we have a lot of airborne pollen out there. We kind of filtered away from trees and now into grasses. And sometimes our reactions, our bodily reactions, the sniffles, tell us what's in bloom, whether it's spring or some of those fall allergies. I always have dogs, and my husband knows when spring's coming because the shedding season starts, right? You just have more piles of fur on the hardwood floors. And so all these different patterns really related to weather and climate. So I threw in there, you know, some pictures of our clothing. We think about our wardrobe is climate, and what we wear today is weather. So climate is kind of a longer term perspective, and weather fluctuates more than climate does. But we can think about the changes in our clothing through the season, the changes in sports. You know, we're moving now, we're into baseball out of basketball. So those sports that we can't really do outside during the winter. So we have these human dimensions of phenology as well. But really, we're talking about the biological events and how they coincide throughout the year. So when humans live together as hunter-gatherers, we need to know when to move to the next area, right? We need to have a way to remember from year to year. We kind of exchange those stories and those oral traditions or written traditions and to teach the next generation. Well, this is when we move because the nut is ready to harvest, or those roots are ready to dig, or the next migrating animal is coming through. And those are cues that we take from the environment. You know, when this is in bloom, it means this plant is ready to harvest. And so as human groups changed to agriculture, you know, in early agriculture, seeds are so critical, so vital, and so scarce. And so we don't want to plant too early because then, you know, we get wet and cold and those seeds rot. We don't want to plant too late because we need the harvest, right? That's the life of our culture, our tribe, is the food that we can harvest. And so there's a timing issue. And so there are all these oral traditions that have been handed down from generation to generation that really have to do with phenology, what to do when. So that's really different than our human calendar, which if you follow the tradition of planting peas on St. Patty's Day in March, you know, March 17th in Ohio, very different than the same calendar date in California or in Florida. Those calendar dates don't really tell us that much. You know, great pollinator example is No Mow May. No Mow May wasn't even created for North America. It was a Great Britain, more pasture-related idea, but people love how it sounds. So if I don't mow in May, it's good for pollinators, right? Well, if you don't mow in May and you live in Florida, very different response than if you live in Virginia than if you live in Maine. It's not the same, weather, the same stage of plants in all those different places. And so long story short, on no mow May, it's really not great for pollinators. It's great for really tall grass, which doesn't really help pollinators, but it gets people thinking about pollinators. But it's that calendar date that really leads us astray. We can't rely on the calendar to do something outside when we have such great variation across the country. So, our friend here telling us when spring is over, same kind of idea, that it really is not reliable from year to year. So there's a lot of our folklore that comes from phenology, and I don't expect you to read through all these, but a lot of those kind of gardening gems that are passed on, what you should plant when, have to do with phenology. And there's a reason that back here, when I was first talking about phenology, I have this picture of a small oak leaf. And many people have heard this tradition that that you should plant corn when oak leaves are as big as a squirrel's ear. Or here I have a mouse's ear. I guess it depends on the size of your mouse or the size of your squirrel. But the idea is it takes a certain amount of heat for those oak leaves to mature enough to push those oak buds out and those oak leaves emerge. And that's around the time that the soil has warmed enough to be able to plant that early corn seed and not lose the crop. We plant lettuce, spinach, peas, broccoli, and cabbage when lilacs first show their leaves or when daffodils are blooming. So that's very early in the season. Later, we're planting tomatoes, corn, peppers when dogwood is in peak bloom or when daylilies start to bloom. So those warm season crops that really need that warm soil temperature. So in the old days, we were here at OSU Extension, we were called the Ohio Cooperative Extension Service. And we really, we have fact sheets, which we still have today. Most all of those are online. But in the old days, we used to have file cabinets full of these printouts of our fact sheets. And most of those were developed by our faculty based out of Columbus. Right, so a professor in Columbus would say, for this insect, you should spray this product, because most things in the old days were chemical based before we really started emphasizing integrated pest management. You should spray this on this date in Columbus 2 weeks earlier if you are in Cincinnati, and 2 weeks later if you're in Cleveland. And so that was kind of the, this whole calendar date idea that take off 2 for Cincinnati, add on 2 for Cleveland, and we should be able to hit everybody in between. Well, we know that, May 15th of this year, probably very different than May 15th of last year or 2012 or 20 years ago, right? And so those calendar dates, not really that reliable. So we have the OSU Phenology calendar. I put the link to find that calendar in the chat box. Hopefully you're familiar with it, but if you're not, we're going to walk through how it was developed and how it might be useful to you. So anywhere in Ohio, it defaults out to today's date, but you can put past dates in, and any zip code in Ohio. So you can actually pull that up right now if you've got your phone or iPad or something handy that doesn't kick you out of Zoom. Go ahead and put in your zip code, and what pulls up is a calendar that we'll kind of walk through what is in bloom, what insect pests might be active. So who do we have to thank for this calendar? This is Dr. Dan Herms, who was formerly with the Department of Entomology, a professor here for a number of years. Now he's head of research at Davy Tree. But he was first in Midland, Michigan, where he was head of integrated pest management for Dow Gardens. And so Dan wanted to have a way to correlate what is in bloom, what's happening out there on the grounds at Dow Gardens, to what insects were in development there on the grounds that maybe he needed to manage or he needed to monitor. And so he started, I like to imagine Dan out there with a yellow legal pad, a couple times a week, writing down what's in bloom today and what insects are hatching, what adult insects am I seeing, or which eggs are being laid. And flipping that page and continuing to write out this scroll of what's in bloom, what's active insect-wise. So he starts that for 6 years in Michigan. Then Dan comes to Ohio State, and picks up that scroll of chronology, what plants are in bloom and when at Sechrist Arboretum in Worcester. And so really details a list of more than 75 plant taxa, so different species and cultivars of mostly horticultural plants. These are plants that were at a display garden or at an arboretum, many of them native, but not all of them. And they're all trees and shrubs on our list. And then the pests, as you can imagine, the insects that are on that list are insects Dan was interested in as the head of integrated pest management for that garden. And so, we don't have a lot of moth emergence, say, or butterfly emergence. We're really talking about pest species. But at the very end, I'll talk about ways that you can kind of create your own list of what really interests you related to the calendar. So you have your own kind of customized phenology calendar. So the key premise of this calendar is that the development rate of plants and insects is temperature dependent. And so we know that in warm springs, things happen much faster. We had all these crazy 80-degree days really early in the season, and we were just moving things into bloom really quickly. And on the other hand, we know that if it's a really cold spring, a slow spring, it takes a long time for different plants to bloom, or before we're really seeing much insect activity. So both plants and insects are dependent on temperatures for their development, and so we can use one to predict the other. Of course, mammals and birds are very different. They're generating their own heat. And their development rate isn't temperature dependent. Their behavior may be temperature dependent, the nest building, the activity levels, but as far as the development rate of the young, that's not ambient temperature dependent. And so our calendar lists then those plants, mostly ornamentals, and those pests that Dan first detailed in his early studies. And then over time, we've added in other species. So the list has grown mostly with some nasty invasive species that have been added to the calendar, but it's not a static list. It's something that we can, it's dynamic. We can keep adding species to that. So let's take a look at the calendar. I put in today's date. So that reflects yesterday's, the end of yesterday's heat index, the growing degree day units. And then I put 43701. You can put, as I said, any zip code in the state. And the first screen that comes up, it drops you right in the middle there. It shows you how many degree days have accumulated, and we'll talk about that. That's a measure of accumulated heat. It's not, we can tell this time of year, it's not days from January 1, it's not the number of warm days. When we're only at 45 or so, that could be a little confusing. Like, what does 45 mean? 1038 is a measure of that heat that's accumulated based on a formula from the first warm day, and we'll talk about this in more detail, above 50 degrees average since January 1 of the calendar year. So here we are dropped into this calendar for today's date. What's to the left here is what's already happened. So anybody see a Japanese beetle emerge? You're either just emerging or about to see them. So Japanese beetle adult emergence we expect to have already happened. Emerald ash borer, 50% of the adults have emerged, and rose bay rhododendron is in first bloom. What's to the right here is what is about to happen. So here's our southern catalpa. It's not yet in full bloom. It's pretty soon that it's coming. Green spire little leaf linden coming into full bloom. We don't know exactly when that event will happen, but we know that it's the sequence remains the same from year to year. Oops. Okay. So if I click on, If I click on view full calendar, oh, if I can't, hey. If I click on view full calendar, then it drops me into Dan's scroll, right? His list of what blooms first and what blooms next and what blooms next, which insects are active. So what happens is I'm dropped into this black bar. So here's me today in the zip code, some of you from Sonora perhaps. What's above that black bar is what's already happened. So our Bumald spirea already in full bloom, azalea bark scale. The eggs have hatched, Japanese beetle, we said, adult emergence. What's below the black bar is what's about to happen. So our large crabgrass is about to come into 80% seedling emergence. Spotted lanternfly, we predict the adult emergence soon. We don't know exactly when, but it's just down the list. So a new feature has been added if you've been using this calendar for a while. Our web guru, David Lonis, is really wonderful with pulling all this data in and putting the calendar together. And so he's been working on this summary button. So I want to show you what the summary button is in case you've been using the calendar for a while or not. So if you click on summary, what David pulls up for you is the last, previous years, so up to 20 years, the average GDD, or growing degree date figure for each year of the last 20. And then an average, so you can kind of compare where we are now with what's average for that date. I find this really helpful in early spring when, we're getting a lot of warm temperatures, and I can't really remember, what was it like last year or 2 years ago? And if I click on summary, then for that calendar date, I can really see, I can compare this year and last year, 2012, if you remember that really crazy year where everything was warm and fast because of some 80-degree temperatures in March, I can compare back to that really warm year and just kind of see where it seems we are. So how is the calendar calculating all these measurements? Well, we have weather stations through USDA and OARDC across the state, and they're taking in all kinds of things, soil temperature, wind, speed, etc. But we're really looking for the average daily temperature. So here's our weather station out at Seacrest Arboretum in Worcester. You may have one close to you, but even if you don't have a weather station near you, this calendar extrapolates for your zip code, and so it's not giving you weather data from somewhere far away. It's really using ISO lines to give you an estimate of what your growing degree days should be based on the map of Ohio. I always tell people it's really important though to ground truth it. So if the calendar drops you in and you're like, wow, my greenspire little leaf linden, it's not even close to first bloom, let alone just coming into full bloom. You just need to kind of ground truth if you're in a little protected area down in a valley, or it's you have a more of an urban area, so things are further ahead for you. The real key, the thing I really want you to walk away with tonight is that the sequence of these events will stay the same from year to year. So even if you say, I'm not exactly here, I think I'm back here, you still kind of know what's happening. You don't know when those events will happen. We can't predict the temperatures tomorrow or the next day, but at least not very well. But the sequence of events will stay the same. Okay, so you can still use one event to predict another. You just place yourself somewhere else in the calendar. If you look around and you say, not exactly. So how do we calculate this degree day? And you saw this, let me go back here to the calendar. So we had these numbers over here. So we know that the average date for first bloom of June bride little leaf linden with that wonderful scent, our honeybees love those flowers, is around 953 growing degree days. That is an average. It's not exactly going to happen at 953, but that's an average based on data from Dan and others. And so let's talk about how those growing degree days are calculated. So I'm sorry, let me go back to this one instead. So we're taking that average daily temperature and then we subtract something called our base unit. So we're making this human research assumption that above 50 degrees, development is happening for all these plants and insects on our calendar. And below 50 degrees, it's not happening. Okay, now we know, and we go back to the example of skunk cabbage, we know that development happens below 50 degrees. It can be well below 40 degrees and skunk cabbage is still metabolizing. But for all these different plants and insects on our calendar, over 75 different plant taxa and over 45 insects and others, we're saying that this is our base temperature. And so we use that base temperature in the calculations. We take the average daily temperature, we subtract the base, and that gives us a measure of accumulated heat for that day. Okay, so what happens is in January, we zero everything out and we say we have 0 degree days that have accumulated. There's no heat units that have accumulated. And for every day that the average daily temperature is 50 or above, we're accumulating heat units. Okay, so if we have a really cold winter spring with not a lot of variation, we may go until early March before we have any degree day units accumulating on our calendar. Because we need that average daily temperature above 50 to start accumulating some figures. So here's our example. So on March 6th, what we're saying is that January 1, we zeroed out, and March 6th was the first day of the year that the average daily temperature was above 50. Our high was 60 and our low was 56. Remember, our base is always 50. So we add our high to our low. This is the simple calculation. And for those of you who like math, it is a sine wave calculation, and our website really goes into more details. So it really is taking every temperature throughout that 24-hour period. But for the sake of simplicity in our example, we're going to use the average, the simple calculation. So high plus the low divided by 2 gives us our average daily temperature. We subtract our base, and we say then at the end of March 6th, we have 8 degree day units that have accumulated. So 8 heat units. Now, that's not 8 warm days, right? It's not 8 degrees above 50 degree daily. It's not 8 warm days since January 1. It's 8 heat units that have accumulated. So that the whole idea of degree day can be a little confusing for people who are new to this, to the calendar, or to the concept. So this is 8 degree days have accumulated then on March 6th. We go to March 7th, we had a high of 70 and a low of 40, but we don't have development going backwards, right? If that skunk cabbage started to push out of that frozen wetland, if it's cold the next day, it doesn't like sink back into the wetland, it just kind of hangs out there until the next warm day when it continues to develop. So we don't use any numbers in our calculations that are below our base, which is 50. So even though we had a high of 70 and a low of 40, we use 50 for the calculation. So our high minus our, we don't use the low, we use our base. We get our average daily temperature of 60. We subtract our base unit, and we have 10 degree day units that accumulated on March 7th. Right, so we go back to yesterday, we add the 8. And at the end of March 7th, we say we have a total of 18 degree day units that have accumulated. Okay, maybe March 8th is cold below 50 degree average. We stay at 18. It could be a week or 10 days or 2 weeks. It just depends on the season. We stay there until we get another day that has an average daily temperature above 50, and then we add some units on. Okay, so early in the season, we just get 1 or 2 or 5, a few units added every day. But then when we get into warmer days with warmer nights, it's really amazing how quickly those degree days accumulate. So here's an example from 2021. This was April 7th of 2021. We had a low of 57 and a high of 83. That sounds a lot like this spring. So our average daily temperature was 140, was at our high and our low divided by 2. Gives us 70, we subtract our base, and we get 20 degree day units that accumulated in just one day. So you can see how those numbers really start to pick up when we have very warm days and warm nights. Okay. So here, just to reiterate that, on January 1, we start at 0. And then we have average numbers on here. So for silver maple, average first bloom around 34 growing degree days. Cornea and cherry dogwood, silver maple full bloom around 42, and so on down the list. It's a little hard to tell from the screenshots, but the insects are in bold and the plants are not. But each of these items on the website, you can click on them. Like if you're not sure what a star magnolia looks like, you click on it and at least a picture should come up of the flower or the plant. Same for our insects. There'll be at least a picture that that pops up to tell you, what is the eastern tent caterpillar, and it'll show you that that webby mass that it makes. Okay. And then here we have either first bloom or full bloom for the plants, and the insect stage could be adult emergence, could be egg hatch. That'll be listed here under phenological events. Right. Okay, so here we are at my house, right? Yeah, here we are at my house, my Massillon zip code. A couple years ago when I was traveling down to the Cincinnati area to give a program. So I plugged on Phenology. So I plugged in my zip code. I was at 352 growing degree days with red chokeberry in bloom, double file viburnum just coming into first bloom. And I was headed down to, so here's our chokeberry. I was headed down to the Cincinnati area. Here I am in Massillon at 352, heading down to Glendale outside of Cincinnati, and they were at 560 growing degree days. And we know this as we drive across the state or from state to state that it's warmer down south. They accumulate these earlier spring temperatures, and their growing degree days accumulate more quickly than ours do as we go north. So in Glendale on the same calendar day, they were just having mountain laurel in first bloom, so much different horticulturally from where I was up in Massillon. And we see that difference, that kind of phenological wave from north to south in the state and really across the continent. So I teach a lot of beekeeping groups. They love to learn about phenology because they're really tied into what the honeybees are bringing back, right? Which pollen the bees are bringing back, which nectar they're working on, and they're really out there. They need to know what's in bloom. Is it time to put those honey supers on? And so as I teach beekeepers from other states, well, let me back up and just tell you we should be really proud that we have this calendar in Ohio. There's really not much else like it around that is customized to you based on your zip code all across the state. Cornell has some really great, other states have some really great phenology sites and research projects, but nobody has a calendar quite like ours. So when I'm teaching beekeeping groups from other states, if I'm down here in Wheeling, I say, just hop over the state line and put in a zip code that's similar. I taught a Newcastle, Pennsylvania group, hop over to Youngstown, put their zip code in, let the calendar come up, and then just ground truth it, right? Are you seeing the same kinds of things in bloom? For a group in Indianapolis, put the Columbus zip code in and see how that comes out as far as what's happening for you phenologically based on what the calendar says. And again, you can just, if you're a little bit further ahead, you just hop down that sequence to say, well, here's where I am, what's coming up for me. Or if it's a little cooler for you, you're going up in the calendar to see what's coming next. So since plant development is temperature dependent, then we can use these phenological events of plants, both to track the degree days, but I'm happy to tell you that you never have to remember growing degree day numbers. I remember that 82 is star magnolia because I'm always thinking about star magnolia in spring because it's when polyester bees are active, but I never have to remember that's the bloom time for star magnolia because it's on the calendar, right? I don't have to do those calculations. So we can use those phenological events and we can create a biological calendar to tell us what's coming up, what pest activity is coming or what plant events are coming. And as Dan was creating this calendar, it was really about pest management events. So we've been able to add pests. This is the viburnum leaf beetle on our native viburnums, especially natives. And we were able to study that beetle and add the egg hatch into the calendar. In the meantime, we've added emerald ash borer, Asian longhorn beetle, spotted lanternfly. Unfortunately, these invasive pests have been added into the calendar. So how do we track the plants? Well, we use first bloom and full bloom as our phenophases, or our indicator phases. So first bloom is when the first flower in a cluster, or say the first flower on a tree of star magnolia, right? When the first flower opens to reveal its sexual parts. Full bloom is when 1 out of 20 buds is still closed. Okay, so if you're taking your own data, your own observations, you want to be sure that you're consistent if you want to compare the information you're gathering with what the calendar says. You use the same definitions for first bloom and full bloom to be able to compare apples to apples. So let's talk about some different ways that audiences use phenology. And first, I'll mention the poster child of the phenology world, which is the serviceberry. Gets its name through phenology. You've probably heard this before, that of course, in the old days, we couldn't have burials of our friends and family that died over the winter. We had to wait until spring, till the ground thawed, so that we could dig those graves. And that correlated, the time that the soil was thawed enough that we could dig correlated with the bloom of serviceberry. So when serviceberry bloomed, we could dig the grave and hold the service for our friends and family that passed over the winter. You may have had a itinerant preacher who came to your little town or holler around the same time when those serviceberry are in bloom to hold that service. They're also called Juneberry because the berries come into bloom, or they're ripe in June, if you can beat the birds to them. Or shadblow, and that's a correlation with the running of the shad when they bloom in the mid-Atlantic. So phenology is used a lot in tree fruit pest management, orchard guides. This is an extension regional orchard guide that really uses the stage of the tree that bloom, whether it's in tight cluster or pink or half-inch green, really correlates with some different care and maintenance, maybe pest management strategies. Here in Ohio, there's a group that's studying hops, that's growing hops, and together they've put together an association and done a lot of observations, because if you grow hops, you can't ask your grandparents what they did for this pest, or it's a relatively new crop to Ohio. So these growers came together, they developed a schedule of pests that they wanted to observe, and then they correlated that with the plant emergence, the plant that they were growing, the hops, but they also correlated this with the growing degree day calendar. So they, wherever they are across the state, can see how many degree days have accumulated in their area, and then learn from each other which pests are active and what their management strategies might be. I mentioned already that beekeepers really love this idea of phenology because of the honey flow. They need to know when to put those honey supers on. And so if the tulip trees are in bloom, this is a great nectar plant. They want to make sure they have lots of room for those workers to bring back that nectar. I use phenology a lot when I'm looking at which bees are emerging, because bees are very seasonal, our native bees. We see queen bumblebees very early in the season when our maples and willows are in bloom. Here's a nice planting of crocus, nice bullseye flag for those hungry queen bumblebees to find. They're setting up their nests early, finding those nests and starting those nests. And I usually think of this around the time that Virginia bluebells are in bloom. I mentioned the star magnolia, and that I'm always remembering, it's the only number I remember for the phenology, the bloom of star magnolia, and that's because it correlates with the emergence of our polyester bees, a little solitary ground nesting bee that actually coats its little nursery cell with a polyester-like substance to kind of waterproof that cell for the offspring. And I look for those bees to be active around when I see star magnolias in bloom, wherever I am across the state. So if I want to see this, a little aggregation at the Toledo Botanical Garden, well, I'm 3 hours from Toledo. But if I put in the zip code for the botanical garden and the phenology calendar, I know when star magnolia is about ready to bloom. So I can kind of plan my visit, hope it's a sunny day, and catch sight of those bees. A lot of our bees are specialist bees. I mentioned our Plant by Numbers project. I put that link in the chat box for you. These are specific little 6x10 gardens using native plants that are focused on specialist bees, bumblebees, and butterflies and moths. So for our specialist bee garden, we have a kind of ironweed, it's actually the iron butterfly cultivar, that attracts this native bee. You can see her white pollen pants here. So this white pollen of ironweed, it's the only pollen that she gathers for her offspring. So just like monarchs have to have milkweed, these specialist bees are very tightly linked to a specific kind of pollen. And they're tightly linked phenologically. When those adult bees emerge, that's when these plants are in bloom. The males and females mate, and then the females are working those plants, gathering pollen to provision cells for their young. Pest management are really what the heart of the phenology calendar was developed around. So here's our eastern tent caterpillar egg hatch. Here's a picture of the egg mass, and that's happening around the time that Forsythia is in bloom. Black cherry, when black cherry comes into bloom, that's a phenological event that the Ohio Department of Agriculture uses to time their aerial spray of BT, which is an organic pesticide used to manage for gypsy moth larvae outbreaks, because they're really devastating to especially oak forests. And so ODA, they have lots of different locations depending on where gypsy moth are most active, all these different counties, all their different zip codes, and then they're tracking the bloom time of that black cherry for the best timing for that aerial application. In creating pollinator habitat, we're always talking about spanning that season with bloom, making sure we have early, mid, and late season plants to allow those long season bees like bumblebees something to feed on throughout the season, or those specialist bees who only need one certain kind of flower to give them the pollen and nectar that they need. So how can we span that season? And although the phenology calendar wasn't developed to demonstrate plants that are good for pollinators, many of the plants on the calendar are great for pollinators. And they're also helpful to help you kind of know, if you're looking for a different kind of plant, you can correlate it with one that's on the calendar coming into bloom. So going for that goal of a landscape with flowers in all seasons. So two of our earliest trees, maples, the red and the silver maple, really great for bees. Willows, we don't have willows on the calendar, but they're awesome for bees, especially those early season queen bumblebees, needing that early pollen and nectar to get their nest started. Here's a plant we're not so fond of, Callery pears, but it is an indicator of emergence of European pine softfly. So if you've ever seen on a mugo pine or other pine, all those little caterpillar-like creatures kind of waving at you, that's our pine softfly, and they correlate with that Bradford Callery pear bloom. So easy to manage in this stage. You can use a sharp spray of water to knock them off the plant. They can't really crawl or fly back. Here in Worcester, you've probably been to Crablandia and seen all the crab apples in bloom. Lots and lots of different bees correlated with crab and apple bloom. Cornell illuminated about 120 different species of bees that will visit apples or crabs in bloom. They're that essential. They're that much of a draw for pollinators. And here's one of those early examples, our mason bees in the genus Osmia. If you're trying to create a collection to teach people about bees, Osmia fill a really important space in your collection, and you really only have 6 weeks in spring to collect those bees, or most of the osmias are only active in spring and won't be active again until next year. So many of the plants on our calendar will help to show when different scales have hatched. So scale are difficult to manage. They're a pest with a piercing, sucking mouthpart that disfigure and really weaken many of our ornamental plants. But if we spray the adult with an insecticide, it's often completely ineffective. We really need those crawlers that we see here on this pine needle. The crawlers out, they're much more vulnerable. And knowing when the eggs hatch can be really tricky. So the calendar shows us several different species of scale and when those scale eggs will hatch. So it allows for some topical treatments of scale. Here's black locust that was really beautiful in bloom this year. I think extra spectacular, and it correlates with adult emergence of bronze birch borer or emerald ash borer. This is my time to tell you that just because an insect is mentioned in the calendar doesn't mean that that's the best time to manage that insect or the best stage. So we don't manage the adults of either bronze birch borers or emerald ash borer. We're more managing we're trying to manage the larval stage. And so just because an insect is at a development stage on the calendar doesn't mean that's the best time to manage it. So this is not a pest management calendar, it's more of a monitoring calendar. Your next step then is to learn about that insect. What are all the different strategies to manage that insect, and then put your plan together for what you're going to do. Bagworm egg hatch, this is a great reason to use the calendar, usually correlates with Japanese tree lilac bloom. So if you have a Japanese tree lilac close to you, you can go out and look at the tree and see if it's in bloom. But you may not even know what a tree lilac is or have one close to you. That doesn't matter. You can just plug your zip code into the calendar and see when those bagworms are scheduled to hatch. And then you can be ready for the movement of those bagworms onto other plants. Since you are right now in beginning adult emergence of Japanese beetle, at least the zip code that I pulled up for Zanesville, one of the best strategies for managing Japanese beetles early on is to go out with your cup of soapy water in the morning and find those early scouts, those Japanese beetles that are on your flowers, on your plants, and kill the scouts. And that it does seem to, it won't manage all the Japanese beetle in your landscape, but it kind of keeps that early population down to a dull roar. Maybe they're going to your neighbors instead of your raspberries. So our calendar is most helpful early in the season, but it does go all the way through. Here we are with June bride little leaf linden that I talked about earlier. The large crabgrass, this is about what stage you are in Zanesville. Here's our rose of Sharon coming into first bloom soon. And then we finish out the calendar with a few insect. Here's a Euonymus scale, the second generation egg hatch. And then we really stop the calendar at that kind of late summer stage, because many of our plants that are blooming in late summer and fall are influenced more by what we saw today, the solstice, the longest day of the year, the decreasing daylight hours, increasing night length triggers some of the bloom for those late summer and fall plants. So we can rely less on the temperatures to predict what's coming into bloom. So I wanted to finish with just a few ways that you can kind of personalize this idea. Maybe you're already keeping a journal, what you see out there, you're farming or gardening, excuse me, or you're, pardon me, or you're a naturalist, kind of making note of what you're seeing. What I do with my phenology observations is I have a little moleskin, just a tiny little notebook. And on one side of this is not it, but on one side I've written out the entire calendar, as you see there on the screen. So I've written, first bloom of silver maple, and then Cornelian cherry dogwood and red maple, and so on. Turn the page, all the calendars written out on the right-hand side. This is a perpetual calendar, so you only have to do this once. So I have the insects and the plants on the right, and then things that I want to correlate, things I'm interested in observing, I write on the left. So on this year, I noticed that it was the first bloom of garlic mustard around the time that Allegheny serviceberry was in full bloom. Yellow rocket in bloom, my yellow epimedium. Sugar maple isn't on our calendar, but I was able to add it by noting the bloom, and it was around the time that saucer magnolia was in full bloom. So you can add your own observations, and as I said, you only have to do that full calendar once and then add in your own observations. Some people do this with a book like the Naturalist Notebook, which is calendar based, but it's a 5-year calendar, and you could write your observations on that calendar date. And then what I encourage people to do is put the degree date next to that, so you have more of that, less influenced by the calendar, more of that biological calendar noted there. My guess is in your pocket, you have over 50,000 photographs. I'll bet some of you have 3 times that many. We can go back to past dates through our photographs and, find the growing degree date that those photos were taken. So, it doesn't tell us exactly. I don't know that this was the first little metallic sweat bee that was out. Maybe it was the first that I noticed, but I do know when I took that picture. Right, so here's an example. I wanted to know when Stewardia fit into our calendar, where it fit. So I know when I was there, this is back in 2013, and it was in bloom. There's a nice bee on there. And so I could go to a calendar, I could put the zip code and the date in and find that it was 867 degree days had accumulated. So I don't know exactly if this was first bloom, in my photograph, or whether there were others in bloom. But I could go back to another Stewardia, watch it, get that first bloom, and really be able to pin down when that happened. Okay. So I hope that gives you some ideas, some ways to use phenology. As I said, it's not the prime time of year, just because so many of our events have already happened, but there's a lot of season left. And depending on your interest, what you're harvesting and when, what insects you're seeing, maybe what butterflies you're noticing, you can always take those observations and try to make those correlations with growing degree days, something you can build on from year to year. So here's my my email, ellsworth.2@osu.edu, and my website, blab.osu.edu. And so at this point, I'm happy to take questions if you have some. I want to thank you for inviting me to come and share with you about phenology. Really a passion that I have.
Denise, that was awesome.
Thanks, Dan.
Do you know, are there other resources out there, like if some of the agricultural pests, and are there people working on that?
Yeah, so because I don't work in field crops, I'm not as familiar with what you can find, but I have been on the Michigan phenology site. They do a lot of weed phenology. So if you're looking for, emergence times to manage different weeds. And then, as I said, Cornell has a site where it's really across many states. So you can put in different locations. I haven't used that extensively. I just kind of was pointed to it this season. But when I put in our zip codes in Ohio, it wasn't exactly what I was seeing outside. So I'm not sure what their base was or what exactly. I just don't know a lot about it, I'm sorry to say. But there really is no other site that is like our calendar with the ornamental plants and those pests detailed.
And then is there, with the bee and butterfly emergence and stuff, you said it's tied more to the plants than it is actually to the growing degree days, or they happen about the same time depending on.
Right. So it depends what time of year. So for most of the spring and early summer, it's those ambient temperatures that are pushing plant development and bloom time. And so bee emergence, so wild bee emergence and bloom time is tightly it's tightly correlated anyway, but it's correlated to growing degree days. But then later in the season, goldenrod, for example, or aster are triggered more by day length in their bloom activity. So we can't, as cleanly track the growing degree day of those plants to correlate them to bee visitation, for example.
Well, does anybody have any questions for Denise? I mean, you can tell that she, just likes her job a little bit, and just full of information. I don't know how you keep track of all that stuff, Denise.
I have a lot of little notebooks, man, and some good search engines, right?
Yeah.
So I mentioned that, Dan had done this work in Michigan, and then in Midland, Michigan and Worcester, taking all this data, looking at all these bloom times and insect emergence, but really wanted to demonstrate that this holds true across all of Ohio. And so we started a project quite a few years ago, 2006, where we had 36 identical plants. We had trees and shrubs donated from some wonderful Ohio nurseries, and we had community scientists at each of these sites across the state to really give us that data that shows that, yes, that sequence of bloom really does hold true, whether you're, in Cleveland and Ashtabula County and Toledo, or down in Marietta, down in Zanesville. That sequence of bloom is consistent.
Well, I have to ask, we did a bus trip over the Chesapeake Bay last year and was able to spend a couple hours at the Mount Cuba Center.
Mm-hmm.
You mentioned one of the cultivars or nativars. Are you guys seeing any difference between the quote unquote native plants versus the cultivars?
So let me back up to phenology and just tell you that you'll notice on the calendar that we do have, if a cultivar was studied, so that June bride linden, then we list the cultivar on there. Because, for example, if you grow lilacs, there's a lot of variation within the cultivars of bloom time. And so we try to put that on the calendar. If a cultivar was studied, we list that on the calendar. As far as pollinator visitation, I mean, there are like Mount Cuba and others who've really done that good research to look at different cultivars and study, are the pollinators finding those flowers? Are they finding the rewards? Some studies say that cultivars are equal. Some are finding them to be better in some situations, and others not as beneficial for pollinators. So I don't think there's an easy answer there. What I like to tell people is, if you really love that cultivar of fill in the blank, of black-eyed Susan or of purple coneflower, go ahead and plant it and then observe the plant in your garden. Are you seeing bee visitation or butterfly visitation? And then also, if you have room, include the straight species. So that's the species that comes true from seed. It's not a bred a clone like a cultivar is. And then you could really compare the two of them visually. What differences am I seeing in the cultivar versus the straight species? There are a lot of good eyes on this question, but it is complicated, and we have so many different cultivars. I mean, you just pick purple coneflower. We have a trial happening at Sechrist Arboretum with dozens of different cultivars of purple coneflower. And we actually have a summer intern who's trying to look at this question of pollinator visitation for just purple coneflower. It'll take her whole summer research project to just focus on purple coneflower and try to unpack that a little bit. Are there some cultivars that were really showing better visitation than others? So then you go to lilacs, and then you go to roses, and then you go to, on and on. It gets really complicated.
And that, I mean, that's interesting, because I think one of the first educational opportunities that I was able to go to Worcester that you had led was one of the exercises was to go out and stand beside a particular type of flower and count how many bees and bugs and insects showed up. And
right. Right.
You know,
It's a great activity. You know, you don't realize how long 2 minutes is until you have to stand in front of one plant and wait till your phone tells you that 2 minutes have expired.
yeah. Well, hey, folks, we are coming up on 9:38. While Denise is with us, I sure appreciate your time tonight. Does anybody have any burning questions? I mean, she is the pollinator educator for OSU. So, and I would, you can either type it in the chat or unmute.
And I will, if you'll indulge me, I'll just put up to take a look at the, sorry, at the Plant by Numbers website.
Oh yeah, that'd be great. Talk to anybody in the office. I take as many as opportunities as possible.
So as I said, we have 3 themes this year: bumblebees, specialist bees, and butterflies and moths. I'm partial to specialist bees, so let me show you this. So for each theme, then we have a handout that you can access. It's a free PDF there online that tells you a little bit about, what is a specialist bee. Gives you a nice design that garden designer Deborah Kanapke put together for us. So kind of looking at the, the elements of design. And then we have plant lists. These are all native. We have first and second options. The first option, some of them are cultivars, but the second option are all straight species. So if you'd rather not plant cultivars, and of course you can plant what you want, but these are our suggestions. Then we show you some places to get more information. What are trees and shrubs that are good for specialist bees? How to find those native plants. So we list, some of the great resources to learn more, how to get those nursery lists and other information. So each theme has then this kind of handout.
Those are all great resources. I mean, and struggling to read in my elder years, pictures are nice.
Yeah, right.
All right. Well, so Lisa says, very nice. Thank you, Denise. Denise, I don't think. All right, last call. Any burning questions?
So I have a couple bits of homework for everyone. So one is to put in your March calendar, maybe it's one of your first events for 2024, put in there in March to check out the Growing Degree Day calendar, because when you really live through the calendar and watch the season unfold, that's when it really starts to make sense. You kind of, you live the plants blooming and the insects emerging, and the numbers make a little more sense. So, so put that in your March calendar to just check the Growing Degree Day calendar out. And then just plant more flowers. I mean, whatever flowers you like, whether they're native or non-native, they're you love your vegetables, you love your herbs. There are all kinds of insects and others out there that need more flowers. You know this, you drive around, you're just not seeing the fence rows, the roadsides, the wildflowers, the lush gardens like the good old days. So plant more flowers, and you tell your spouse, I told you, you got to fill up the trunk.
Yeah, my wife did a pretty good job this year. I think we've got more flowers than we've had the past 19. Well, I mean, that's interesting too, because driving down the road, you don't have to use as much bug remover on your windshield anymore than what I can remember as a kid.
Right. We don't have to clean our outdoor light fixtures as much. It's, we just see an overall decrease in insect biomass, which is not a good thing.
Well, Denise, thank you so much. Thank you for what you do. Always a pleasure. And thanks everybody for being on. Next month, we're going to have a forestry program. I can't remember the date offhand, but we will email that information out. Everybody have a have a safe evening, and Lord willing, next June, Denise will have you back.
I love it. Thank you so much. Thanks, everybody.
All right, everybody have a great evening.